Hello class and Professor Paradis. Today, Myungjin and I are excited to introduce our project, a prototype chicken farm designed with Arduino components and software. Our main goal, to explore how technology can enhance farming practices by automating certain tasks and improving efficiency. Within our farm, we've implemented 3 key systems, a water refill system, a lighting system, and a security system. These systems work together to ensure the well-being of our chickens while minimizing the need for constant human intervention. The water refill system keeps our chickens hydrated by automatically replenishing their water supply when needed. Meanwhile, the lighting system regulates the chickens' exposure to light, mimicking natural daylight patterns to promote healthy growth and egg production. Finally, the security system helps protect our chickens by monitoring the surroundings and alerting us to any potential threats and predators. Throughout this presentation, we'll talk about the inner workings of each system, explaining how Arduino hardware components and software enables us to achieve our goals effectively. So now let's start by talking about our water refill system. The purpose of the system within our prototype chicken farm is to ensure a seamless and efficient water replenishment process for our chickens. By automatically detecting the weight of the water and adjusting accordingly, our aim is to optimize water management while minimizing manual effort. So the system functions by continuously monitoring the water level in the container using a weight sensor. When the chickens consume water and the weight decreases, the system triggers a refill using a 5-volt water pump. Once the water reaches a certain threshold or is deemed full, the refill process stops automatically. So as seen in the slide, we are using a 5-volt water pump, a 1 kilogram weight sensor, an external power supply module, and a 9-volt battery, as well as a HX711 load cell amplifier, which we'll talk about shortly. So there's 2 goals of having this system. Firstly, it ensures that our chickens always have access to a fresh and adequate water supply, promoting their health and well-being. Secondly, by automating the refill process, we reduce the need for constant manual monitoring and intervention, thus freeing up valuable time and resources for other farm tasks. Here's a circuit diagram and a picture of the water refill system. As seen, we are using an external power supply due to the fact that the digital pins of the Arduino Uno board do not have enough voltage to power the 5-volt pump. We're using an HX711 load cell amplifier to accurately measure weight. It has a 24-bit analog to digital converter for precise readings. The setup helps us monitor water levels in containers and refill them when needed. And here's our code for the water refill system. We use the HX711 ADC library's read file and the loadcell.get data function to get weight readings. Then we used if-else statements to detect whether the water was below or over our set min and max threshold. If our weight value was below our minimum threshold, we'd use digital write on pin 7 that is connected to the pump to instruct it to be high, thus pumping the water to the chicken water supply. Or we'd set it to be low, thus not pumping the water, if the weight value was over our maximum threshold.
The purpose of our security system within the prototype chicken farm is to protect the chickens from potential threats posed by predators and intruders such as foxes, wolves, or eagles. With the installation of the system, we aim to provide protection to our chickens, ensuring their safety and well-being at all times. The system operates by using an HC SR04 supersonic sensor strategically positioned around the perimeter of the chicken's enclosure. This sensor continuously monitors the surrounding area for any approaching objects or movement. In the event that a predator or intruder breaches the enclosure after midnight, the sensor detects their presence and it triggers a buzzer to emit a loud alert signal. Furthermore, to ensure swift action in response to the intrusion, our security system is integrated with an ESP32 board capable of sending instant notifications to the farm owner. This real-time alert system enables the owner to promptly address the situation and take necessary measures to protect the chickens from predators approaching. In practice, here is our circuit diagram and a picture of the setup. Feel free to pause and take a look at the setup and the circuit diagram. For the implementation of our security system, we began by setting up the HC-SR04 supersonic sensor in front of the chicken's enclosure, connecting it to the Arduino board. We defined the trig pin and echo pin to establish communication with the sensor and configured the buzzer pin for alert notifications. Then within the setup function, we initialize serial communication and define the pin modes for the sensor and the buzzer. Moving on to the code logic. In the loop function, we first triggered the sensor to send out ultrasonic waves and measure the duration it took for the waves to bounce back. This duration was then converted into distance using the speed of sound formula. We use the if-else statement to determine the action based on the measured distance. If the distance was less than 1 meter, indicating a potential threat within the set range, the buzzer was activated using the tone function. Otherwise, if the distance was greater than or equal to 1 meter, signifying no immediate danger, the buzzer was turned off using the no tone function. Through this combination of hardware setup and code, we created a security system that protects our chickens from predators and intruders. The purpose of our lighting system is to ensure that our chickens have a consistent source of light even when natural sunlight is insufficient. By integrating LEDs controlled by a photoresistor, we have created a solution that automatically supplements ambient light levels to maintain optimal conditions for our animal. This setup not only enhances the chicken's quality of life by providing adequate lighting throughout the day and night, but also contributes to improved productivity and well-being. With the photoresistor sensing changes in ambient light, the LEDs are activated as needed to ensure a steady light source for the chickens. By automating this process, we reduce the need for manual adjustments and interventions, thus allowing for more efficient management of our chickens. Here is our circuit diagram and a picture of our setup.
So in terms of the implementation of our lighting system, our Arduino Uno board will read using the analog pin A1 of the photoresistor. It will read a value, and we set a value threshold. So in this case, it is 60. So if the sensor reads under 60, then it will digital write the pin to high, so the LED will turn on. Well, else, so if it's over 60, then the LED will stay low, so it is day outside. Therefore, the LEDs are off. So now, at last, we will show the circuits in action. Okay, I have my system all rigged up. Right now, there's around enough water. So as I drink the water, the weight sensor is going to read that the water gets low, and the pump will retroactively pump water in. Well, it takes some time for the weight reading to go down, as seen here, because it's not instantaneous. But okay, so now let's watch. So now the pump activates since it senses that it is under 10 grams, and it will stop when it sees that it's over around 40 grams. So voila, the automatic refill water system works. Okay, so now I will demonstrate the security system. So here we have our buzzer and our supersonic sensor in our chicken farm that is set up with a cardboard box and prototype. We also have the water refill system there that's connected to the pump and the water source. So right now, it's reading around 27 centimeters, which is the length of one wall to the other. And so I put the if statement to be if distance is less than 27. So for instance, if a predator walks in here, it will trigger the buzzer, which will alert the chicken and tell them that there's a predator inside of your cage. So we can see, oh, and here there's nothing. So yeah, the security system indeed works. Okay, do it again. Independently, which is good. So they all worked. But unfortunately, we have to scrap the ESP32 board part of the security system, as ordering the part was out of our budget, And also, the weight sensor had a delay problem, so the reading wasn't instantaneous, but so like there would be a delay between the water pumping and it stopping. But we fixed it by tweaking the code, so like we just lowered the threshold by a bit more so that it would stop before it actually hit the threshold. But by the time the delay, then it will hit the threshold.
In summary, our prototype chicken farm combines Arduino hardware and software to make farm work easier and keep our chickens healthy. We have built 3 main systems, one for water, one for security, and one for lighting. The system helps us provide a steady water supply, protect our chickens from predators, and give them the right amount of light. By automating this task, we can save time and effort while ensuring our chickens have a good life. We hope that our demo video showing how the circuit works helps you see how the system fit together. We're excited about the potential of these innovations to make farming more efficient and sustainable.